When creating a program, you will often want some sort of graphical representation of the objects you're working with. In Tetris, you'll want an application that shows little colored squares, and for Doodle Jump, you'll want a screen with platforms and a doodle character. Creating objects graphically from scratch is actually really difficult, but Java provides us with some pre-written classes to make it easier. JavaFX is a library or collection of objects that Java developers have written for you to use in your code when you want to add graphics to your program. You can think of JavaFX library in the same way you think of CS15 support code. When you use support code, you reference the Java docs we've written for you that contain descriptions of the classes and methods that you can use. JavaFX also has documentation in the form of Java docs that can be easily Googled and used as a reference. An important JavaFX class is the stage class. This class represents the window of your program and is often passed into the start method in your app class like this. The JavaFX stage class has a method called show that, when you call it in your start method, will make a little window pop up. This is your program. In order to start adding graphical elements to this application, JavaFX requires that you set the scene of the stage. To do this, you have to instantiate a JavaFX scene object and pass it into the stage's setScene method. When using JavaFX objects, you have to import them at the top of the class in which you are using them, as so. To find the path to the specific object you want to import, just look here in the Java docs. Now you can add graphical objects to your scene. All graphical objects that you add to a scene inherit from the JavaFX class, called the node class. Instead of adding many nodes directly to our scene, we add a single root node to the scene. This node, in turn, contains the other nodes that you need in your program. Typically, the root node is an instance of the pane class. The pane object essentially functions as a container for other nodes. You can think of it like a behind-the-scenes organizational tool. Looking at the Java docs for the pane class, you see that there are a number of subclasses that inherit from it. All panes have a getChildren method. This returns a list of nodes that are contained within the pane. To add an object to that list, you would do pane.getChildren.add and then pass in your node. The pane subclasses all have unique methods that allow you to add nodes to them in particular ways. The border pane class, for example, has setTop, setBottom, and setCenter methods, which add the nodes to the pane similarly, but also align them with the border pane's top, bottom, and center, respectively. Remember that panes inherit from the node class too. This means that you can create a pane within a pane, which is useful for complex graphics. In CS15, you're almost always going to be dealing with more than one pane. For this reason, we will create a class called PaneOrganizer, whose function is to organize the panes. In our program, let's say we decide we want a border pane as the root node. We would create an instance variable that stores a border pane and initialize it in the constructor of our PaneOrganizer. Don't forget to import the border pane class. We can then instantiate the PaneOrganizer in our app class. Now that we have a PaneOrganizer instance, we need to add the root node to the scene. Remember that our root node is stored in the variable root in our PaneOrganizer. In order to get access to that node in the app class, we will write a getter method that returns the pane stored in root, like this. To add the root node to the scene, we'll look at the Java docs and find that there's a specific constructor that takes the root node as a parameter and modify our code as so. Notice that simply creating the border pane logically in the PaneOrganizer wasn't enough. You had to graphically add it to the scene. This two-step process for creating graphics holds true for almost all JavaFX elements. Some of the objects you're going to work with most often are shapes. JavaFX has a shape superclass that many useful shapes inherit from. If we look at the Java docs, we see all the subclasses. Clicking on circle, for example, gives us information about the circle class and the methods we can call on it. Let's say we want our app to have a row of circles near the bottom of our screen. Since we want more than one circle in that location, we could carefully add each circle to the bottom of our root pane. Or we could create a pane just for the circles and add that pane to the bottom of our root pane. We can write a method that handles this functionality and call it in our constructor. Now that we've created a pane for the circles and have added it to the bottom of the border pane, Notice that two-step process again. We can create some circles. We look at the Java docs and find a constructor. This one allows us to specify the circle's location, radius, and color in one line. Running the program now looks like this. Where are our circles? We forgot to add those circles to a pane, so they didn't show up graphically. If you created an instance of a JavaFX object and aren't able to see it on your screen, make sure you've added it to a pane and that all of your panes have been added to your root node. Adding the following lines will fix this bug. JavaFX also provides you with classes called event handlers that help you incorporate user interaction into your program. For more information about event handlers, reference the lecture slides or the lab handout. Remember, when dealing with JavaFX objects and graphics, you want to keep this checklist in mind. Did I instantiate a JavaFX object? Did I add it to a pane? Did I import the correct JavaFX object? Did I set the location, size, and color of the object? If you're sure that you've done all of the above, your graphics should appear mostly the way you expect them to.